Yeah, I think we're going to
Yeah.
get started now, too.
Awesome.
All
Awesome.
right. So, welcome everyone. Thank you so much for joining us today for the Bay Area OWASP Hacker Days, Visualizing the Void of Security Audit Data, featuring Jake King. I'm your host, Aureen, and I'm like Jake with CMD. Um, Travis, I'm not sure if you're online, but I want to thank you and your team from Bay Area OWASP for partnering with us and helping organize this event with us. Couldn't have done it without you. Before we get started, I just want to go over a few quick housekeeping rules and notes, not really rules. All the attendees will be muted by default, but if you do want to submit any questions or comments, we welcome you to do that in the chat feature, and we'll answer them at the end during the Q&A portion. And if time doesn't allow us to answer your question, we'll make sure that we follow up with you separately. And finally, as you guys probably have noticed, this webinar is actually being recorded, so you can reference it later. Keep an eye on Meetup with the YouTube link. And that's all. So our speaker today is Jake King. Jake is the CEO and co-founder of CMD. He's a longtime security practitioner specializing in infrastructure security, primarily in cloud environments. Before he started CMD, he managed the security program at social media giant Hootsuite, where he experienced firsthand the risks pertaining to Linux systems at scale. He frequently speaks on the topic of Linux security at B-Sides and MITRE. And for those who don't know Jake very well, I just want to give a few fun facts. In case you haven't already heard, he is an Australian native, so I hope none of you are too surprised by the accent. He could do an entire lecture series on breakfast burgers, beets, and his family's olive tree in Australia. So I am sure he loves that more than anything else in the world. So be careful if you get him started. Take it away when you're
Thank,
ready.
thank you, Lorraine. It's wonderful to be joining the group here. I'm a huge fan of the OWASP chapter in the Bay Area. I've been watching a number of the videos in the series, and I've taken part in one of the events actually a while ago now, before all of this COVID stuff happened and everything kind of turned into pandemic mode. So I first and foremost wanted to say thank you for building such an amazing community in the Bay Area. I also wanted to mention I'm not actually, obviously in the Bay Area right now. So this is an awesome opportunity to get to work with and present to some folks that are outside of my kind of immediate circle here in Vancouver, BC. And so, I think I think this awesome kind of approach of being able to share and kind of communicate online like this in a really open way is really, really awesome. So thank you so much for having me join from Vancouver. The side profile is because I'm in a tiny Vancouver apartment, if you weren't on the line earlier on. But today we're going to be talking about a couple of very specific things that I'm really passionate about, more so than olive trees sometimes, but I do like the olives. So I wanted to talk a little bit about visualizing the void of security audit data, and really the importance of not only being able to communicate this across your company, how to capture it, what it's used for, but realistically looking at it in a pragmatic and modern way, outside of kind of your standard SIEM stack for kind of security event analysis. So as Arain mentioned, a little bit about me. I've been in the InfoSec industry for about 10 years, but I've been focusing most of my career prior to joining, kind of a company to kind of work on blue team work. I actually spent a lot of time red teaming systems. And so a lot of the experience that I've had throughout my career has been tied to a number of different initiatives, primarily breaking into systems, trying to work out gaps, trying to work out ways to obfuscate logs or obfuscate monitoring systems. And as part of that, I got a really passionate kind of kind of strike to my name a few years ago, when I started to really identify that audit data was really, really fun, and just as fun as breaking into a system was, actually trying to defend that system was really, really entertaining as well. So for those that are entertainers, blue teamers, red teamers, purple teamers on the call, hopefully you find this information really valuable. I'll be making the slides available after the fact as well, but I did want to cover a few of the things that we're going to go over today, just to outline kind of my thought process of how I've gone through this presentation. First and foremost, a lot of the times when I'm asked about audit data, process data, shell interaction, history, command data, all of these kind of things, how to capture it comes up is a really common topic. And I'm not going to just throw, a config your way or kind of tell you to use one particular vendor tool. CMD is a security vendor. Obviously, you can come and take a look at our stuff if you're interested, but there are plenty of open source options out there for you to really get a good understanding of what's going on in your environments. From that point, I actually want to tell to you about how we leverage machine learning and a number of models at CMD in very basic senses. And we've actually put some examples together of how we've used artificial intelligence and machine learning to not only highlight threats within our environment and visualize them using some specific industry tools, but actually how we're leveraging machine learning to minimize our search space and optimize the kind of things that we're looking for when we're actually going through audit data and actually getting some value out of it, even without kind of visualizing it in a creative graph way, looking at that data itself and being able to process it. Looking at some common abuse patterns that you should really kind of look out for when you're actually coming into an environment that is leveraging some kind of artificial intelligence, machine learning, or even signature-based detections. And a few of the things that I've used to obfuscate or evade logging and monitoring tools. And then really just some basic processes for enriching and processing and visualizing the data that you've actually got. And for me, communicating it effectively to executive teams. One of the things that we often overlook as security practitioners is how we show the value of what we're doing with our cool science projects at the office to our managers, to our boards of directors, to our investors. And this is something I'm really passionate about. Using tools that they're really familiar with can be super valuable. So without further ado, I kind of want to talk about not only what we're covering, but where this is coming from. We founded CMD in late 2016. My co-founder and I both come from an infrastructure background. I'm very much a red team, a security tester, infrastructure guy. I've spent a lot of my career focusing on really, really sophisticated attacks, all the way down to kind of the run-of-the-mill rudimentary stuff that hits the edge of the firewall and bounces off all day. But when we started CMD, both of us, both Maloon and I, had a really strong focus on user interaction with production environments, primarily because number one, it was going away. And number two, it was the source of most of the breaches or kind of the impacts to our production environment in general. And we both come at this from very, very different directions. And so over the last few years at CMD, we've collected about 100 billion events. We're growing at about 1 billion a week. It's about 70 terabytes of data that we're able to post-process, consume. And this is only the data that our customers have opted into allowing us to post-process and investigate. We're literally dealing with hundreds of thousands of unique interactions with systems in every single hour. Right now, the average login events are kind of topping out at 90 to 100,000 events every hour. And when we look at that kind of event count, we get a really broad perspective. And it's information that I love to share. And as Arain mentioned, it's information I've shared at the MITRE attack groups, with the B-Sides community, and more recently with some of our free product offerings for the community to leverage and use as well. But one of the big things that I've wanted to be able to do throughout my career in security is gain better insights into how to really analyze massive amounts of data and really kind of hybridize requirements. We have a lot of customers that have very different security requirements, very different postures and perspectives around how they're going to lock down systems, what they're going to be looking for, and really what things they can't even store. And so we had a very difficult challenge to solve. And it wasn't going to be done by, just looking at every exec on the system, because if we were doing that, we'd be flooded with information and obviously it wouldn't be super valuable to everyone. And so often the question I get asked is, why shell interaction? It's one of those questions that I think can be broken up into a couple of different parts. We don't want to just look at shell interaction through SSH or SSM or, Cloud Shell. We've got to think about interaction with a system, interaction with a host. This could be through, a Docker exec, a kubectl, an interaction in some form or way where we're pushing an execution, either stateful or stateless, to an environment that we're running a workload within. And when we think about that kind of paradigm, we want to look at lower volume, higher quality data sources that are a little bit more ad hoc and really kind of more interesting from a security perspective. The second reason that we look at shell interaction is it's relatively easy to collect and parse, but it's really easy to process for outlier detection. When we actually approach security topics with a lot of our customers, a lot of the folks that we've worked with, and actually a lot of people in the past, looking at very detailed, very advanced kind of detection methodologies isn't really high up on the priority list, but looking at the basics, getting the number 1, 2, and 3 kind of controls out of the way are really the things that we want to move in the right direction. One of the other things that we've noticed is a lot of ad hoc interaction comes through shell interaction. So we're not looking at your application writing a file to a log, or we're not necessarily looking at your Nginx proxy, routing traffic to a different backend, or HA proxy, basically load balancing traffic to different nodes for its backend service. We're looking at ad hoc actions that are running within the system that are often automation or adversarial behavior in nature. And so one of the questions that we often get is, hey, we've locked out SSH, we've shut off API access through our containers and our pods, and we don't really have anyone in production. The next question I often ask is, how do you know? And so really kind of configuring some of the topics and kind of processes that we're running through today can give you some good insights there. But often it's the source of how these systems drift, how they change. And so when we get into this a little bit further, I often get asked the next question, hey, CMP is a commercial solution, but I don't have any budget, I don't have any money, or I'm a student, or I want to play with this kind of stuff. What can I use today? When I go through the list with a bunch of folks in the industry, finding out what people are using is really interesting to me. I see the majority of environments using eBPF sensors, sometimes exec snoop, sometimes other tools, and forwarding them using kind of event forwarding systems to a centralized logging service, usually Elasticsearch, Logstash, that kind of thing, standard pipeline. We see a lot of Audit D tracing being used, some EDR, some host intrusion detection, and obviously some native controls and native cloud tools that are kind of pushed along the way. And all of these sources of information are going to be pulling different points of information from your host and your system. Pretty obvious stuff. We've all seen all of this stuff in environments before, but really understanding what these tools are really doing is going to give us a better picture of how we can leverage that data to not only understand where threats are in our environment, but how to automatically detect those threats, either through signatures or through patterns of behavior and analysis. And so when we take this, we drop these hosts on we drop these tools on our hosts, we let them run for a few weeks, and we end up with this. We end up with a log rotate that's 15 days, 30 days, 60 days old. We end up with some gzip files that are going to end up in a directory. We churn and burn the host because we're fully ephemeral, fully moving forward, or all this data just ends up in a bucket, and we usually use a grep for session open and the user that we're trying to figure out, who did what, who done it. When we look at these kind of data points, one of the most interesting things that I often see is it's incredibly easy to tamper with. And it's the kind of thing that I would go first as an adversary and make changes to, right? Step 1, turn off history logging. Step 2, turn off Audit D. Step 3, clean up your act. And Step 4, kind of act on your objectives. And when things get out of hand really quickly, as security practitioners, often what we do is just delete things. But developers also delete things. So, things just go missing. And when they go missing, it becomes incredibly difficult, right? It becomes incredibly difficult to not only identify what went wrong and how it went wrong, but why it might have gone wrong in the first place. So creating a culture around why security is important to your organization and why security should be treated really seriously, why these logs are actually important, is part of the journey. But centralizing these logs is obviously also critical as well. And so that's really that first step for a lot of companies that we work with. Looking at logging solutions and centralizing them and growing them and planning accordingly and all the basic stuff, right? And the one pro tip I would say is when you're going about kind of collecting this audit data, even turning on Audit D and forwarding it to that syslog server and just archiving in a bucket is going to get you further ahead when your auditor, when your assessor, when your breach analyst comes in to try and figure out what went wrong. These are going to impact us all at some point in time, whether it's a reliability issue, a confidentiality issue, or an availability issue. There's always going to be challenges in those environments. So one of the typical things that we like to see coming from our customer environments when we speak to companies, when we talk to people about their insights, Audit D is really the gold standard. And when we look at Audit D, forwarding to a different server, forwarding to a centralized system, it can be super easily configured for session and TTY recording, which is the kind of interaction we're talking about today. But really one of the tools that I love to bring up in these conversations as well is the tool set that Brandon Gregg had developed a number of years ago with a massive amount of the community just down in the South Bay area there, called eBPF. It's an eBPF project, and the BCC project down there has been an incredible part of not only how we've gained a lot of telemetry in a performant way, but broader system information altogether, file interactions, binary interactions, system interactions, and doing these in such a way as to not impact the performance of our workloads. Audit D can be fantastic when it comes to attribution, analysis, kind of execution and capture of that data. But where we often find we fall short is when we're going and running Audit D, it's an incredibly heavy performance burden. Sometimes it doesn't even work in the environments that we're running. One of the other things that I will mention though, is when we've captured that right data, when we've got a little bit of insight into what we need to see, seeing a little bit of the telemetry, seeing some of the exact data, seeing some of the patterns, log forwarding used to be a really hard topic. It used to be a really difficult conversation with my ops team. They'd be using our syslog, it'd be sent over the wire unencrypted, 514 UDP. It was terrible. But today we've got so many amazing, amazing, amazing choices as to getting lines off box and doing it in an effective way. That the tools like Vector have been a personal favorite of mine for a few months, and prior to that, using the Beat stack from Audit Beat stack specifically, but the Beat stack from Elastic to really get lines off box and understand what's going on. Not only this, but cloud providers have also stepped up to the plate as well and provided a lot of CloudTrail and access logs into buckets in JSON format that is parsable and processable. So tools like SSM, if you're using them to access fleets of systems, or you're leveraging some of the container native functionality within GCP, can add some of this logging of system interaction and service interaction directly for you as well. So using sources that might not be too expected is totally an option for you right now. And really, kind of the most important thing around all of this is defining what you want in the first place and understanding why it's going to be important. Okay. So when we take a look at that audit data, when we've captured those defaults, when we've set up the principles, when we've set up those basic kind of topics, looking at ways that we can not only turn that data into something that's valuable today and immediately for the incident that's in front of you, or immediately the incident that you've just resolved, but building consistency over time becomes incredibly important. And why I call this out specifically is because when we version an API or we make a change, it's super easy for us to adapt and tell our customers to roll over. But when we're now moving back in time and looking at audit data or historical trends over our environments over time, what we can often find is that when we're approaching these problems, consistency challenges become inherent in every design that I've seen out there. Right, we've either got some poorly versioned logs, some inconsistent tagging, differently structured JSON objects, or failures to fetch, GeoIP information as part of our enrichment pipeline. This has happened to us dozens of times. It breaks the JSON object, we write it to the bucket, and we can't parse it. It's got to require fixing. Looking at timestamp consistency and transformations to make it make sense to us. Just looking at companies that I've worked with that have had non-standard timestamps, time zones set on servers and infrastructure in the first place, and they've collected data in UTC, PST, EST, and AEST, for example, and ending up with a massive transformational mess at the end of that year, trying to correlate behaviors and actions when something went a little bit sideways. Things as simple as file names and sizes, even conventions around where you store them in a bucket or where you store them in your data set become incredibly important as well. And not only that, really OS configurations. One of the biggest challenges that I've run into again in recent times is the audit subsystem changing some of the offsets, adding white space, adding some different characters. And this does break pipelines, it does break tools. And so these are considerations that we have to have. But I think one of the other things that we often don't think about is really enrichment of that data over time. Looking at points in time and how we can enrich that data and potentially even backfill information about extra, kind of attributes, extra things that we've learned about that pattern or that execution over time. And so at CMD, obviously enrichment of data is part of our journey as a company, looking at GeoIP history, looking at, GeoIPs and history of that IP address, looking at the trends over time for how much adversarial behavior is kind of centralized around that IP, even the impact of, kind of local events that are only impacting our company. So for example, firewall, IDS, and SIEM logs correlated with our system interaction, looking to see if those kind of map over time, but also how you store that in a consistent way. And a lot of that boils down to that first point on this slide, documentation. Really understanding, writing it down, talking about what it means, and discussing a common nomenclature within your company, within your organization, to make sure as you pass on the torch to another security engineer, another practitioner, or even a developer trying to do some analysis, everything makes sense. Don't develop custom naming conventions. Don't try and kind of do this in a strange way. There's plenty of fantastic standards around common event models, common event names, and even common tactics and techniques that we don't need to do that ourselves. So think about these kind of things before you get into this kind of massive journey. And if you're in the journey already, going back to try and rectify some of these challenges is worthwhile doing today, because it is incredibly hard to do in the future when you're actually going through an incident. I can't imagine how much time I've wasted in incident response, simply trying to figure out why a timestamp was off, why something didn't map, or why a username, a user offset was incorrect, specifically on Linux systems at least. So, when we get into a lot of conversations with folks, again, the visualization stack comes into play. This is probably going to look pretty standard for a lot of folks. I've actually replaced the audit beats component to this with Vector because I actually really like Vector, and we use it with ES internally at CMD. But when we look at patterns of behavior across different environments, across different systems, we have a very traditional approach to storing data. And as security practitioners, we often lean on the tools that are already rolled out as part of a development cycle, already rolled out as part of an engineering kind of initiative. And so this standard stack is usually incorporating a tool like Elastalert to maybe create some alerts or logs around anomalies, or even using some of the basic capabilities of the narrow time or the short time machine learning or artificial intelligence capabilities of ES, and visualizing those in Kibana. But really, when we look at this stack, it's got one large flaw. And that large flaw really ties to kind of longevity of that data. And so when we think about longevity of information across our organization, security intelligence isn't necessarily about the problem today, yesterday, or last week. It's the problem that happened at the start of the year when someone changed the SSHD config to allow root login and reset the root password. We need to go back in time to really understand what happened, where it happened, and why. But storing all of that data in Elasticsearch is not only incredibly cumbersome, but it can be very, very costly. And I'll go through some of the concepts there as well. But the typical stack that we've used to enrich this data set, alongside our native kind of corporate tools, our paid products, and even some of our free tools, is leveraging GCS, the bucket storage engine, and Google Cloud, Dataproc for data enrichment, and BigQuery to actually allow us to run data queries over that massive data set. Now, we'll get into a little bit more information about all of this as we go through. But it's this BigQuery, Dataproc, and GCS combination that gives us the ability to not only look at near-term information in real time, but look at long-term information in relatively high fidelity. But obviously, we're going through a lot of data. When you look at stacks, ES, Elastalert, and Kibana, they're fantastic for near-term search. They're fantastic for immediate visibility, immediate kind of value. And sometimes even that immediate alerting and query could be very dynamic. But when we're looking at security intelligence, we've got to kind of think of patterns of behavior, common events, common models that we want to kind of get a little bit deeper into. And so when we think about the limitations of those platforms, a hybrid approach makes sense. It's low cost to store this data in buckets. It's incredibly easy to take advantage of bucket policies to migrate and copy and even post-process data to make the cost reductions even greater. But it's even more important to really design consistent patterns around how you store in those buckets and what you're doing with them. So when you go to ETL it into the tool of your choice, maybe even you want to push it back into Elasticsearch to run some queries over a very specific time base, you want that to be consistent. You want it to be, obviously usable. The one thing that this becomes really difficult for is it's not really suited to real-time controls or alerting use cases unless you get really creative. And so that hybrid approach of having something like Elastalert in place is going to give you that real-time notification of someone running a sudo command or doing something strange in production, or even just running an exec if you're in a headless style of environment with zero touch and zero interaction. And it certainly plays to our strengths of really understanding some of those models. But really, this talk isn't necessarily about just catching the data. and I have to start with some of those basics, because often when we have these conversations, people don't really know where to start. And that's totally fine. Getting into analytics on this information is even more complicated. And what I do want to kind of mention here is the number one challenge that we often find with a lot of companies that we work with, a lot of folks that we talk to, isn't so much about the machine learning, anomaly detection, artificial analysis, statistical kind of anomalies that we're going to pick up, because that's stuff you can see in Elasticsearch today. It's basic things that you can look in other tools that you've got in your environment. It's when you're looking at long-term statistical analysis, it's when you're looking at long-term trends that it becomes very, very difficult to kind of handle these large data sets, do it in an effective way. And obviously I've talked about some tools that can allow us to run massive queries over massive amounts of data. It can be kind of expensive. So really one of the things that we focused on at CMD in the early days, and we still focus on today, is not necessarily around leveraging artificial intelligence and machine learning to, kind of find the needle in the haystack in the first place. It's to leverage signature-based rules and policies that are incredibly reliable and incredibly robust, but expensive to run over large data sets, through a subset of the information that we've collected over that amount of time using association rule learning. And association rule learning models are incredibly popular with our team, primarily because it gets our noise down. It's not just basic statistical analysis that kind of provides us some, interesting insights, but really it gives us a lot more information about, what's actually going on in our environment, what's actually going to be interesting, and what would even be worthwhile querying. So when we're applying specific filters or going through specific events, we don't want to miss events and we don't want to miss data. So I'll talk to some of those points in the next couple of slides. But what we wanted to do was solve that noise problem. And so at CMD, we really started to kind of automate and identify a lot of the automated activity in environments. One of the things that we've done in an engineering cohort as engineers over the last 15, 20 years is we've tried to automate everything. We've tried to orchestrate everything. And when those ad hoc actions happen, it's just that one time that I need to do it. So one of the things we found really common in at least environments that we're working with is SSH is really, really commonly used for repetitive tasks. Often it's some kind of tool like Ansible logging into a system, checking a few file states, or repeatedly logging in to kind of update, user roles or properties or permissions. Container environments are even more consistent with the kind of interaction that we see. One of the things that we often see is liveness checks inside Docker environments or, kind of Kubernetes environments for network telemetry, process telemetry, CPU and kind of container information and orchestration. But one of the things that we've also found is that within each runtime, we're also finding that, these environments produce very consistent data sets. And so I actually have an example of how we've been able to use PySpark and Dataproc with the FP growth model, which is a really basic model that anyone on the call can try. Anyone can jump in and play around with a data set they might already have, or even some sample data sets you can get online for really kind of identifying frequent patterns in that data set. This is typically used for, kind of common suggestions. Jake likes to buy apples, and everyone that buys apples wants to buy beers. Maybe Jake wants to buy a beer. So the common kind of pattern that we've found in some real world results have been in 1,000 container environment over a 24-hour period. This is a pretty common use case for us, to be honest, folks. $250,000, just over $250,000, under half a million kind of events that are interesting to us, but 365 million executions and 10 million invocations of a shell, right? Like this is a pretty common pattern. By just going through and identifying and classifying the kinds of behavior in that environment, using these existing models, even basic models, we're able to kind of identify that 82% of the traffic within that environment, the information that was in that environment, was something that, number one, we needed to keep for compliance reasons. It was an automated task and a liveness check inspecting that container. It was something our auditors, for whatever reason, wanted us to track. But was one of the other things that became really interesting. It was the remaining shell interaction on those systems was such a small subset of that data captured. It provided a really interesting, very high quality, very, very small search space for us to really identify what was going on within that environment. And again, it was one of those really interesting use cases for us where we were able to take that data set, reduce it to a point where two factors stood out. And it was not only root shell activity, but it was root executions running through Docker APIs. These were, again, correlated with different data sets, signature-based policies, and we'll talk through some of the signature policies that we use at CMD, the ones that we see commonly out in the world. But they were correlated with these different data sets and models to give us an understanding of what out of that smaller subset of information was actually valuable to this organization. And these have now been brought into product. They're now being used in different ways. But again, these are generic properties and principles that you can use in your environment today. So when we think about lower volume, does it always mean higher value? Absolutely not. When we look at data over time, over massive amounts of time, especially when we're looking at shell interaction, we think about human interaction, we think about lateral movement, we think about insider threats. And these are the three topics that I actually mentioned at the top of the call that we were going to cover a little bit in depth today. And I'll go through some of how we've pulled out features from different events within our environment, even just using a standard audit D configuration with TTY monitoring enabled to pull some of this information out of that data set, capture it, and actually turn it around into something valuable. So for user behavioral analysis, obviously we can go through and use some industry standard models. There's a bunch of stuff on GitHub that we can kind of pull immediately. But really what's going to kind of move the needle for us is deeper analysis into not only the shell interaction through interactive sessions, but non-interactive sessions, non-behavioral kind of based patterns for users, and really classifying that data to capture trends over time and identify what someone's doing. Lateral movement in the scope of geolocation, source and destination, and IP analysis, obviously pulling this stuff short term into Elasticsearch or kind of other SIEM tools of choice is going to be doable. But over time, that trend data changes, especially during times of COVID. At least I'm going back 3-4 months to look at trend data over time for access to our production environments, our environments and APIs, and looking to then cluster different kinds of user activities. So if I'm in Vancouver, am I able to track my activity around Vancouver? When I tether to my phone because my home office went down, when I go back into the office because something changed or I needed to do something, when I clicked that alert on my phone and did something on my mobile and call. But also using insider threat detection, leveraging some really basic natural language processing, not only looking at the executions themselves, but actually what the user typed. And this might sound counterintuitive, but we're not necessarily looking for executions that succeed all the time. We're looking for attributes that are passed in or arguments that are passed into a binary, the kind of ordering that you do with very specific arguments and flags on something like Vim or LS, but also leveraging NLP to understand typos. So when we're looking at error counts in environments, really understanding the kind of problems that a user might run into during a shell session, and obviously how that applies to a different subset of data. So when we think about these three models, I want to go through a couple of examples, and then I want to talk through how we can kind of visualize them. But talking about visualization, we've often looked at taking a screenshot out of Elk or taking a screenshot out of a SIEM and sending it to our leadership team as a way to win. One of the things that I found a few years ago was actually while I was working at Hootsuite was how effective using tools that executive teams leverage themselves for visualizing business intelligence information were at communicating security trends and topics, simply because the visualizations were common and they felt familiar to these group of individuals. While it's not only about executive reporting, what we're trying to do is unlock budgets. We're trying to unlock time and days. We're trying to unlock staff so we can start to do our jobs more effectively. So the typical pipeline that I've used to create some of the visual insights today is using Vector with the CMD-free agent on a host, leveraging GCS and PySpark on Dataproc to add some enrichment, some filtering, and some consistency, forwarding that data into BigQuery, and then leveraging Data Studio, but really in these visualizations, Tableau, to create some business intelligence dashboards to show activity over time and to communicate to my leadership team what I'm doing as a security practitioner to improve things for our environment. In this case, covering those three use cases: lateral movement, insider threat detection, and obviously adversarial behaviors. So when we think about those tools, inherently, they're not really designed for security intelligence, but we're seeing amazing insights of these tools being kind of leveraged in many, many, many different ways. So when we think about BI tooling, it is traditionally designed for massive data sets. It's statistically able to deal with those massive kind of requests that we're going to do. And when we're forwarding a subset of the information that we've collected, going through our reductions in search space, we're actually able to leverage a lot of the powerful visualizations in these platforms to do some pretty cool things. And I've created some really basic ones today, just based on some sample data, actually pulled from an environment that I've been working with for some time to kind of demonstrate these. But really that key concept that I've found really effective is the addition of threat intelligence interleaved with some of this search space reduction and some statistical analysis can actually produce a really insightful report for your environment. And again, there's free trials of all this stuff available all over the place. So one of the pro tips here that I actually take on is really starting with behavioral analysis. And this kind of leads into a bit of insider threat detection. Some of the stronger features that we've identified, at least in the time that we've been spending analyzing command and execution information, have really tied to things like time of day, day of week. As long as it's consistent, kind of thinking back to what I was talking about previously, and coordinating that information from human resource information systems or building management systems. Now, sometimes this data is actually in Tableau already for things like ENPS tracking or employee time of day access, those kind of things, or building statistical analyses. So in a number of cases, I've been able to map my data in production with data around building and access controls and map those user accounts together. Thinking about it in a more traditional sense, there's a number of models that are out there on the planet for command execution classification. Hey, read the man page, tell me the word cloud, classify Vim as a file editor, classify Nano as a file editor. But going through and looking at arguments that are leveraged and the ordering of arguments, looking at execution patterns, so staged executions, sudo su, su jake, that kind of thing, and really standard error and exit codes, really typos inside the shell. This one has been the most interesting because not only have we been able to use this for behavioral analysis of new engineers, we can actually look at stress levels of engineering teams as part of some of these insights. Unfortunately, we can't use this data set across a lot of our customer environments. We've been able to do some tests with mock data because there's so many privacy requirements around performance testing for engineering that you can't really get into, but super exciting stuff is available there for you to sink your teeth into. But extended authentication and authorization, things like multi-factor authentication, different PAM steps that you might be leveraging, or authorization mechanisms that might be validating the kind of activity that you're doing. Say you're using a credential as part of a MySQL query to a backend database, or using a loopback interface in a container or a cloud instance to find out metadata about that instance. Excuse me, pulling a token from the kind of activity that's on that system, or really even foreign environment variables. There's a number of different properties that you can see from the client side that are passed along into the user's session when PAM is configured to do so. This has actually been incredibly helpful for us to be able to look at users logging into a system, potentially using a shared account, and different ways to identify that kind of access. So the two kinds of kind of clusters of features that we're going to use in today's visualization that I'll show you are really looking at offset from UTC, coordinated data from HRIS, and some execution frequency analysis. And it's most commonly kind of tied to that execution frequency analysis in the visualization that I've created. So how does this kind of work together? As part of an analysis, what we did is we classified the kind of users in our environment. This is one user's activity over the space of an entire year. And when we look at this activity over the space of a year, you can see a lot of different things going on the left-hand side here. The left-hand side of the screen shows the colors as servers or systems. Unfortunately, I wasn't able to show a lot of that information. It kind of exposed a little too much. We can see on the left-hand side the execution path for the binaries being run by this particular user. And on the kind of columns that we see there, we can see the days of the week. Now, clearly, the outlier looks like it's that session on Sunday. Again, you think that the model would kind of pick that up as an outlier, and it definitely does. But when we correlate this kind of information with insider threat metrics or insider threat kind of signatures and patterns, we can actually start to truly understand what is going on in the system and why it might be important. So when we look at the exec path in a subset of that data, we were able to run our models and identify not only why there might be interesting behavior on that system, but a number of the sensitive executions that were running within these kind of different execs over the year that might be of interest. We identified through this that a couple of common binaries were being used in this named account. And that was sudo and Docker, and they were running Docker execs in an environment where it was relatively unusual to do so. There's a couple of other different environments that kind of stood out to us. There's a few staging environments that aren't highlighted here, but this enrichment was done by our model by grouping this and clustering it slightly differently than a number of different behaviors. And it was classified slightly differently because not only were those common binaries and named accounts being used in a pretty consistent way, but what we were able to do was look at session interactivity and shell interactivity as a property. And the unique component between these two types of interactions, one was interactive, one was a SSH session at a terminal, at a TTY. They were hooked. They were looking at what they were going on and doing. We saw some ad hoc executions that weren't super common in automated shell scripts and tools, LS, for example. And what we were then able to do is differentiate between automated use of this named account and manual use of this named account. The third property that we're able to identify for this particular insider threat was actually the fact that it occurred on a Monday. And this particular Monday, when it was tied to the HRIS system, was a day that this person was out of the office. They were away from work. They were off work. So it was kind of combining these three data sets that gave us some really great insights into how we can look at something very unusual, like a user interacting with the system independently, running a Docker exec and actually jumping into a server in a container, doing something a bit unusual. and comparing that data to what they were doing typically. Now, look, just looking at it visually, it makes sense. These are the different kind of events. But when we were really kind of going through this massive amount of session information, it can become very cumbersome to try and find these needles in a haystack. So super awesome stuff. Have a look at some of these features in your data set and see if you can start to pull out and extract some of those features. And again, use some basic classifiers to try and determine some of these factors for yourselves. When we think about that second component that I talked about, lateral movement is another interesting component that we've typically seen in SIEM tools and SOAR tools in immediate style and way. What we've often found is lateral movement is tying to source and destination checks for IP connectivity. I'm jumping in on one host, I'm laterally moving to the next host, or I'm laterally moving using a non-standard port as some kind of network telemetry. While this is super interesting, there's one other concept within Linux that actually proved to be more interesting for a lot of our users. While that pivot is relatively common within many environments, what we were actually finding is lateral movement within single host was being done through switching of user accounts and leveraging privileged access to do so. So the common chain of events that we were seeing, and this was detected by, again, a model looking at dimensions of user, login user, and exec user, and how many multiple dimensions they were seeing, was someone would log into a system, they'd sudo su to root, they'd su to another user, given that root privilege, and then they'd su to another user as well. Now, this was breaking the chain of a lot of the audit tracing and a lot of the audit data that was found in that environment. And just using a couple of things like the login user, the binary execution mapping, and in this case, multi-factor authentication failure using some of the capabilities of our software, we're able to identify very quickly that this was happening in this environment, and that lateral movement, even though it was on host, I like to call it user pivoting, but that lateral movement, even though it was on host, was very, very interesting to see the kind of dynamic changes that were being made. Typically, this is manifested by a user logging into a system and having a different diversity of execution users within that system. But where this gets incredibly difficult is when we're looking at dimensionality of this. In this case, we can see that, Alex has logged into a system as Alex, apt, and he's logged into a system as Alex and run commands as Alex, apt, and root. Now, root might be relatively common if you're in a sudoers group. We can correlate that again with BI data, group data information. But we might also want to look at different ways to kind of group this in different patterns. We can see that Alex, in this case, was probably running a sudo su, privilege escalated to the root user, and then obviously kind of extended that session over time to another day of the week. Now, where this became incredibly interesting for a number of the folks that we were working with over the last couple of months is when user accounts were laterally moving into other user accounts. What we're able to do with this visualization was not only determine shared accounts. So in this case, root is a shared account. Everyone is logging in with a named account, privilege escalating. What we're able to find out was that there was a number of other shared account users and groups, and just simply looking at the executions over time could give us some ideas as to where those executions were sourced from, where they were coming from, and what they were doing. So when we take this a little bit further, leveraging some of the not only detection policies that we're using, but threat intelligence and threat insights to really understand what out of that subset of data, leveraging some of the cool patterns that we've found out is actually interesting information. So a lot of you may have been wondering how I was able to highlight that abnormal kind of privilege escalation, file deletion, and kind of some tampering of security tools in one of those previous graphs. But what we're able to do is leverage the MITRE ATT&CK framework to map TTPs through this subset or this reduced search space of data to really actually highlight and give some really thoughtful insights into what users were doing on the system. I actually ran this query the other day. This was run over probably about 100 billion events, which was search space reduced by about 50%, to highlight 3 indicators of compromise that we look for relatively commonly. Now, 14% of your alerts in your environment were coming from file permissions, file deletion, and disabling of security policies and tools. You'd probably be pretty worried about it. Now, when I reduce this subset even further to exclude things like automation tools, deployment software, and even some of the maintenance and management systems that were cleaning up and deleting files for cron jobs, even log rotate running on the system, this search space reduced even further. These alerts were very high quality, and we're able to leverage some of them in an actual report to present to our leadership team. So leveraging these TTPs can be a really difficult task, especially when you're not a red teamer. Fortunately enough, I had a fair bit of experience going through as a red teamer to start to pattern match, start to see how my systems acted to different behaviors, different patterns of behavior in my systems. And I was able to kind of run through a number of examples: privilege escalation, running some exploits, doing some shady things, running raw syscalls, doing all kinds of crazy stuff as part of that environment workflow. But what we were able to do was leverage a tool called Atomic Red Team by Red Canary to identify a lot of the TTPs that are used in Linux environments commonly. There's another couple of really great repositories of these. One of the other ones that I think is notable for conversation today is the GTFO bins website, where you can pull a number of one-liners, some really great things, and kind of map them to different attack tactics and metrics. But one of the things that we also noticed here was that these aren't necessarily kind of one size fits all. So we were finding these adversarial behaviors, we're able to run them as executions on systems, we're able to capture that information, train our models on what bad behavior looked like, and obviously, create some alerts and policies around them, reduce the search space, filter out a number of the items that we wanted to filter out. But what we also wanted to do was kind of automate some of this testing. Atomic Red Team let us do this with this simple Python framework. In this case, what we're able to do is looking at something as simple as a set UID, set GID exec being run on a host. And we're able to build a policy inside of our SIEM tool to alert us on this automatically. When we were running this query over a larger set of data, set UID, set GID is used a lot in package installations. It's used a lot in different kind of software installations. And so reducing that search space using some of the algorithms we discussed previously really gave us a subset of the information to search through, and looking at that trend data over time, we're actually able to build some really clear insights into our environment. So kind of taking this a little bit of a step further, looking at those exact events that were highlighted in our systems became super interesting. What we were finding was usually these kind of events were run in interactive shells, interactive sessions, and you can kind of see by the date here, we were able to go all the way back in time to see the first time cron tab was modified, looking at the first time that shadow files were tampered with on systems. And it was matching not only on that reduced subset, but really kind of leveraging TTPs to highlight really sensitive events. And these are just some screenshots of the kind of things that you might be able to see if you're logging and recording some of this audit-based data, specifically for shell interaction. Interesting things about these two sessions: both had been invoked through Cloud Shell on GCP. Both had been run in a staging environment, and both had been run by the same user as a shared user account, and it became very difficult for that organization to try and map these two kind of procedures together. Now Cloud Shell actually allows you to kind of map a user ID to any execution on this system, so this is less of a problem today than it once was, but it is still an attribution challenge and a nightmare, especially when you don't have this level of observability. So this doesn't really stop just at kind of those false positives that might be caused from finding and seeing all this data and running it over your entire data set. One of the biggest challenges that we've found really going through a number of kind of these models, a number of these analytics, is data poisoning. And this is a really serious problem, specifically within the security industry. In general, because we find that running different commands, running different data sets, running different tests can become very cumbersome, and it can become very tiresome. When I'm going through an environment and trying to train my entire data set, look at the automation, look at the orchestration tools that are in there. If my developers make a change, or if my, obviously my developers, make a change purposefully to poison the way that my model is going to process what they are doing, obviously this is a challenge. So one of the ways that our team has been looking at improving some of these challenges is really looking at some real world use cases. So our financial institutions are really leveraging a number of anomaly detection tools to ensure that traders aren't really dealing with kind of under the table deals, or kind of, preempting different things by correlating call center information with cell phone information, location information, and obviously other tracking points. But investigating the poisoning in real world cases gave us some actual mitigation strategies. So some of the solutions that we actually found were really sampling techniques that can be used in conjunction with ensemble models, which is really kind of running two models in parallel, different days, different times, different weeks, different structures of that information, even with some manual review. And this is a supervised kind of approach to kind of determining what might be really interesting, but also looking at reducing that kind of comparison of the results for classifiers in a statistical way that allows us to do it at points in time. So going back into January 22nd of this year and running an assessment of what a user was particularly doing, what that user was actually trying to achieve. But even going further and deeper into that analysis, by trying to do that over multiple points in the year, trying to look at common patterns, common behaviors, and obviously mapping it together. And when it gets really hard, we're actually dealing in adversaries, when we're dealing in people that are trying to obfuscate, trying to evade these tactics and techniques. They may be trying to do very, very abnormal things. One of the biggest components in the security industry, or I guess proponents of the contributors to these kind of models in the security industry, are going to be a lot of the threat detection EDR vendors out there that are looking at obfuscated binaries, obfuscated malicious malware, obfuscated one-liners, different things that are running on a host that could kind of look suspicious, kind of look interesting, or maybe actually be a little bit detrimental to the environment. One of the things that we've found is that research has really demonstrated ways to obfuscate through polymorphic malware. We're obviously seeing a lot of different ways to kind of, evade these kind of models within object recognition in driverless cars and vehicles. But one of the things that we've found, again, is that ensemble learning model can really combine multiple detection techniques and tactics to actually, kind of offset some of these changes that adversaries might be trying to implement. And really leveraging a number of anomaly detection techniques, the first time an execution is run, the first time a binary argument's used with a particular flag, and pushing that through for manual analysis, and then again, correlating that with some threat intelligence data. So again, when we think about some of these problems, it doesn't stop here. I didn't want to give this entire presentation and provide 10 code examples and 15 different things. We've done a lot of that at CMD. And so 2 articles that I think would be super helpful if you're looking to instrument an actual control stack, you're looking to look at implementing some observability, looking at some existing models, and actually playing with some sample tools that you can have a look at. I actually presented at the MITRE ATT&CK Summit earlier this year on evasion in container environments, looking at different ways that our customers are adopting a number of open source technologies, ML, AI, and MITRE ATT&CK to combine and build very compelling stories around their infrastructure and environments. But one of the other really great resources that I found, even just talking through some of the concepts that we've discussed today, is some of the misconceptions about leveraging ML in cybersecurity. It was written by our lead data scientist, Dipali, who went through a number of different topics and tactics as she's been divining and building out a lot of the technology that I kind of highlighted a little bit of today, some of the things that you can take advantage of in the community, and really kind of gone through a number of the misconceptions that often people find. So I guess without further ado, I wanted to say thank you for obviously letting me go through this session today with you. Hopefully we've got some time for questions. And so again, thank you so much. And I guess I'll check the chat, Arain. It looks like there's a couple of questions that are there anyway. So happy to, yeah, it's one of those things. I'll double check some of this as well.
Thank you so much, Jake. That was, I don't know about everybody else, but I found that incredibly rich. So I'm sure there are, please, if you have any questions, put it in chat and we will get to them. But in the meantime, Jake, I actually do have a couple questions. One of them is anonymous. So what is one of your favorite unsung hero tools you use for Linux security?
Oh, unsung hero tools. I've been a huge fan of a number of different kind of, well, I guess I'll kind of answer this in 2 ways. I've been a huge fan of a number of different kind of IDS products over the years. Massive shout out if anyone from the Suricata team is on the call. I've leveraged Suricata for years and years and years for threat intelligence and analysis of network traffic. And at CMD, we're now starting to correlate some of that activity with some of our customers. It's an amazing, amazing tool set. But one of the, I guess the other thing that that kind of comes to mind pretty immediately is really the BCC toolchain and the eBPF open source projects on GitHub from Brandon. Over the last few years, he's definitely provided some amazing insights to the community as to how to detect and obviously evade kind of different tools. But obviously the performance impact there has just been amazing. To see the actual performance monitoring and logging for Linux has been huge. So I guess those 2 are probably the ones that I'd call out.
Beautiful. Thank you so much. I think we're gonna wrap up the session here. If anybody has any questions that we missed, feel free to email Jake. You can also find him on Twitter. You can also learn more about Jake and CMD at the link you see on the screen, cmd.com/bay. Once again, we are recording this, so we will get the recording up on YouTube as soon as possible and share it out on the Meetup group. So make sure you keep an eye out for that. Thank you once again to Travis and the whole team at Bay Area OWASP for having us and organizing this event. And of course, thank you to Jake for all of his knowledge and taking the time to do this. So I hope everybody has a great rest of their day, and thank you so much.